Today we'll be learning about cycle of a star. Contents: what is a star, stages of a star, star birth, star death, and some interesting facts about stars. Moving on, what is a star? As we know, a star is a luminous ball of gas, mostly hydrogen and helium, held together by its own gravity. Nuclear fusion reactions in its core support the star against gravity and produce photons and heat, as well as small amounts of heavy elements. Star birth. Interstellar cloud. Stars are born within cold, dense clouds of gas and dust. The process of star formation may be triggered if something disturbs the cloud, such as a collision with another cloud or a shockwave from a supernova explosion. Second step, fragments form. Now, unstable, the cloud breaks up into fragments of different sizes and mass. The most massive and dense of these fragments are gradually pulled by their own gravity into tighter clumps. These shrinking fragments will eventually turn into protostars. Protostar. A protostar forms. Gravity pulls material into its core, where the density, pressure, and temperature build up. The more matter the original cloud fragment contains, the greater the temperature and the pressure rise as the protostar develops. Spinning disk. The growing mass at the center creates a gravitational pull, drawing even more gases and dust inwards, a bit like water going in a plug hole. The material being pulled in starts to spin around. Powerful winds develop, blowing jets of gases out from the center. A star is born. Squeezed by the force of gravity, the protostar's core becomes so hot and dense that nuclear reactions occur, and the star begins to shine. The glowing core produces an outward pressure that balances the inward pull of gravity, making the star stable. It is now a main sequence star. Planets form. Not all the material from the gas cloud has been used to make up the star. The leftovers form a spinning disk of gas and dust around the star. This debris may be lost into space or it may clump up together to form planets, moons, comets, and asteroids. Star death. Star can die in 4 different ways, all of which are shown in this video. Our Sun, a typical star, will follow the central path, but not yet. It has enough fuel to keep shining for 5 billion years. When larger stars die, they turn hydrogen into heavier chemicals elements such as carbon and oxygen, which are later recycled to form new stars and planets. All the atoms in your body were created this way. Stable star. Very young star goes in through stable phase in which it shines steadily. Possibility A. Small stars. Stars with less than half of the mass of the Sun fade away very slowly. Once the hydrogen in the core is used up, the star begins to feed off hydrogen in its atmosphere, but it doesn't generate enough gravity to use another elements as fuel, so it slowly shrinks to become a black dwarf. This will take far longer than the age of the universe, up to 1 trillion years. Star begins to shrink. Second, light intensity fades out and fuel runs out. Third, star continues to shrink and fade. Fourth, light becomes increasingly dim. Black draft. Finally, its fuel used up and its light extinguished. The star becomes of the size of the Earth. Possibility B. Medium-sized stars. When a Sun-like star has used up the hydrogen in its core, nuclear fusion spreads outside the core, making the star expand into a red giant. The core collapses until it's hot and dense enough to fuse helium, but eventually it runs out of helium too. Finally, it becomes a white dwarf and its outer layer spreads into space as a cloud of debris. Star expands. Red giant. Nuclear fusion spreads to the layer around the core, heating it up and making the star expand. Nearby planets may be swallowed up by the growing giant. Planetary nebula. The star's outer layer dispersed into space as a glowing cloud of wreckage, a planetary nebula. The material in this cloud will eventually be recycled to form new stars. White dwarf. All that remains is the dying core, a white dwarf. This Earth-sized star will slowly fade and become a cold, dead black dwarf. Possibility C. Massive stars. Stars over 8 times more massive than our Sun end their lives in strange and violent ways. The heat and the pressure inside the core become so great that nuclear fusion cannot only fuse hydrogen atoms together to form helium but can fuse helium and larger atoms to create elements such as carbon or oxygen. As it takes place, the star swells into the largest star of all, a supergiant. Star expands. Red supergiant. The star has grown into a supergiant. Nuclear fusion carries on the inside the core, forcing atoms together to form heavier and heavier elements until the star's cores turn into iron. When this happens, the core no longer generates enough outward pressure to resist the crushing force of gravity, and the whole star suddenly collapses, causing a catastrophic explosion, a supernova. Supernova. The star self-destructs in an explosion brighter than a billion suns. Its outer layers are blasted into space, but its massive core continues to collapse on itself. What happens next depends on how massive the core is. A smaller core becomes a neutron star, but a massive core never stops collapsing. It shrinks until it's billions of times smaller than an atom and becomes a black hole. From the last stage of the massive star's cycle, it either becomes a neutron star or a black hole. Neutron star, up to 3 times heavier than the Sun, yet as a few kilometers wide, neutron stars are unimaginably dense, fast-spinning stars. Black hole. The force of gravity close to a black hole is so intense that nothing can escape from it, not even light. Anything falling inside is torn apart by gravity and then crushed into a point of infinite density. Interesting facts. Today I'm going to tell you two interesting facts. The first one is 13 billion years, the age of the oldest known star. And the second is 1600 light years is the distance from Earth to the nearest black hole. Thanks for watching this video and please subscribe and like this video. And don't forget to hit the notification bell for more videos like this. Thank you.